Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. These next two chapters represent exploring data using charts. And in the first chapter, we're going to talk about using charts to spot the patterns in data. And then in the next chapter, we'll focus exclusively on how to do that with KNIME. But let's begin by simply setting the table and making sure we understand all the correct terminology. Humans view information graphically, visually. That's the way we draw information quickly, not by looking at spreadsheets, but by looking at charts, because we're so easily able to see the patterns in the data. The spread, the center, its shape, unusual features, distributions, outliers, it all pops out so quickly and clearly when you view it graphically. As a good working example, spotting the center of a graph when you're looking at a distribution. It's very easy to just visually spot the center. Right here I can see the center is clearly 5. The spread when looking at a chart refers to the variability of the data. In other words, the range when we looked at it for measures of variability. In the example on the left, for example, you can see that the range, the maximum is 7, the minimum is 3, so the range is 4. On the right, you can see that the range actually is from 9 to 1, leaving a range of 8. From a graph, the shape and the distribution can be described by two characteristics. The symmetry, which is basically how both sides from the mean seem to mimic each other. And so dividing it in the center and looking at it as a mirror. And then the number of peaks. Is it a single peak, which we would call a unimodal, or is it multiple peaks, in which we'd call bimodal? And we'll show you examples of each and why you might see them. We will also be able to see from the shape the skewness. When they're displayed graphically, you'll see that it tends to some of the distribution of the observations seem to shift more to the left or to the right of the mean. So instead of this typical bell curve shape, we see something more unusual. And the uniformity, when we see observations in the data that are equally spread across the range, seemingly indicating that it's not a simple bell curve again. Essentially, it means that there's no clear peaks. So let's look at a quick example of each of the 4 of these. Symmetry can be divided in the center so that each side represents or looks like half of the other side. The symmetry can be positive or negative, as you see from both the left and right in this example. A skewed distribution is one that has more observations on one side than the other. On the left-hand side, looking at the left-hand chart, you can see it's skewed right. There are more observations. And on the second one on the right-hand image, that would be skewed left. Now the number of peaks from the shape that I can draw allows me to identify a unimodal data set where there is a single peak, as you see on the left, and a bimodal data set, as you see on the right, where there are 2 different peaks. And we're going to show some examples of some social characteristics where that type of thing would occur. When you see a unimodal distribution, this shape is commonly referred to by most people as the bell curve. Though it's commonly known as the bell curve, it's more accurately described as the normal distribution or Gaussian distribution. Finally, in the shape, uniform distributions show a data set with 0 peaks, and that we would again refer to as a uniform distribution. There's very little information I can obtain from that. One of the features that I can draw from visualization is outliers. When you see the number 9 shown on this chart off to the right, I can see that it's not really part of the distribution of the current values. It's very easily for me to identify that as an outlier and something I can then take care of with IRQ ranges. Now a gap I can also spot, and the gap would refer to an area where there are no observations at all. In this case, the value of 5 seems to be clearly missing from the distribution. So let's look at what I can identify from this chart right now. I can see that it's centered over 4, that the range is from 1 to 7, that it's symmetric with a single peak, and that it is bell-shaped or a normal distribution. So I was able to gather a great deal of information simply by looking at this data set graphically. All right, let's try another. I can see in this case that the distribution is skewed to the right, that it's centered right now over 2 or 3, roughly, that the range is again from 1 to 7, and that there are no gaps and there are no outliers. And let's try just one more. Looking at this chart, I can see that it is non-symmetric and that it is bimodal. I've got multiple peaks. I see there's a gap in observation at 4s and with no outliers visible, that my range is from 0 to 8, and it appears to be roughly centered at 4, despite the fact that there are no observations at 4. So again, I can draw lots of information by simply looking at a histogram of my data. Of course, I've been dealing with quantitative data. When you're dealing with qualitative data, you can still represent this as histograms. However, it does not lend itself to these same types of interpretations by shape. I can still see a skew of data from one to the other, but the order that you put them in can change that skew. The bottom line is qualitative data in terms of centrality and shape and spread is not really applicable. So in summary, we're going to identify the center of our data, the median of our data set, using graphics. We can identify the spread, which will show us the range of the data. And through the shape, we can identify its symmetry, skewness, the number of peaks, and the uniformity of the data. And we cannot spot unusual features, including gaps and outliers. That completes this chapter of the class. Feel free to move on to the next chapter.